Hello everyone and welcome. We continue our discussion on continuity by looking at the types of functions that are continuous. The following functions are continuous on their domains. Polynomials are continuous, rational functions are continuous, root functions are continuous, trig functions are continuous, and inverse trig functions on their domain. Let's build some continuous functions from other continuous functions. If f and g are continuous at a, if both f and g are functions, so are the addition of these functions, which makes a new function f plus g, f minus g, f times g, c times f, where c is a constant, and f over g, as long as g of a is not equal to 0. The function f of g is continuous as long as it is defined at a. Determine whether these functions are continuous. F of x is equal to x squared plus 5x plus 2. Now, this function is a polynomial function. So remember what the definition of polynomials are. It's functions like x in the base and positive integers in the exponents. So like x is 0, x is 1, x squared, x cubed, and so on, with a variety of plus or minus signs. That's fine. These are polynomials, and we said polynomials are continuous on the domain. So they are continuous. This is a polynomial. So it's continuous on the domain, on its entire domain. The domain of this function, continuous on negative infinity to positive infinity. Okay. F of x is equal to radical 1 minus x. And so what we know about root functions, the square root function in particular, is that the domain is limited to where, so it'd be continuous. So this is the root function. It's continuous whenever or wherever whatever is under the radical is greater than or equal to 0. So 1 minus x greater than or equal to 0. We'll solve for x. That's where x is greater than or equal to 1. Right. So it's continuous on this domain, negative infinity to 1. 1 is included. So your answer is there. Okay, let's talk about the special theorem called the Intermediate Value Theorem. That's IVT. So it says if f is continuous on a closed interval AB, and m is any number between f of a and f of b inclusive, then there is at least one number c in the interval AB such that f of c is equal to m. If we want to think about a diagram of what this might look like, let's say a and b, these are x values. So that's a and b. And then there was f of a and f of b. So f of a is somewhere here, f of b could be somewhere there. There's some letter m between f of a and f of b. What you're saying is, regardless of what the function does between a and B, there must be some point between A and B where there's some letter C, whose function value is M, right? So it could be higher, the M could be here, whatever, wherever it is. There is some, as long as this function is continuous, as long as f of x is continuous in this interval, then there must be some C here that matches. All right, so what we are talking about is intervals, right? There must be some, so if M was 0, there must be some number, right? If M was 10, there must be some number between A and B, right, that matches. Some x value, C, whose, if you plug in C, the f of C will be equal to M. Okay, so let's do an example. F of x is equal to x squared. F of x is equal to x squared, but x to the 5th power plus 17x minus 10. And I want to show that it has a solution in 0, 1. Has a solution in 0, 1. F of x. Right. We say it has a solution, it means that it has a 0 in the interval 0, 1. So f of x, so this is their function. Now that was f of x. It means x, so the 5th power plus 17 minus 10 equals 0. It has a 0, right? So that means that if you sketch this function, it would have some point where this function crosses 0. Okay, there is some x value for which this crosses 0, and you're told that it is in the interval 0, 1, right? So how can we check that? Between x equals 0 and x equals 1, from either direction, either this graph is going from positive to negative, or it's going from negative to positive, right? So our check then, if it has a 0, that means that we're either going from positive to negative, or from minus to plus, right? Either way. So let us check f of 0. F of 0 be equal to 0 to the 5th power plus 17 times 0 minus 10. That gives you negative 10, so that means that f of 0 will be some negative number. Right, so we've shown that the f of 0 is really some negative number. Negative 10. And the f of 1 equal to 1 to the 5th power, so 17 times 1 minus 10, and that gives you 8. So we've moved from a negative to a positive. And so we have shown that somewhere, right, this graph, somewhere, some x value, we don't even have to say exactly what it is, but we know it's in this region, right? 0 to 1, there's some x value for which this graph, right, so there is some f of c, some c, such that f of c is equal to 0 because we have moved from negative to positive, okay? Because the signs change. Signs change. Change from negative to positive in the interval 0, 1. Okay. That's it. Thanks for watching. Please like and subscribe. And see you again next lesson.